second part of the NLP lecture, fifth. In this lecture, we will analyze the text using online tool available on my website. So first of all, you have to go to cs.uef.fi/himmat and /ACI2. I will also copy the link of this tool in the description of this video. So this tool is like a text analyzer, text mining, and web content mining. So in this, using this tool, we will analyze the content of the text of any web page. For example, I have opened one web page, bbc.com. You can see lots of text here, and text is scattered over in a different position, and it's not like a homogeneous text. It's like a separated under the HTML structure. So it's like a complex text, not easy. So we have to analyze the text in order to get the useful information and make it better for the decision making for the business. So first of all, we go and please insert URL here. We can say bbc.com. You can write complete HTTP www whatsoever, but you can also write shortcut bbc.com and press enter or press go. It starts loading. Once the loading has been completed, then it will gives you the analysis on the text. So it downloads the text, a complete text, sentence by sentence, word by word, a complete clean text after removing HTML and everything. And it gives you the language of the text is English. For example, if you just give any Finnish web page, it gives you the language of the text would be Finnish language. You can see the clear and clean text of the web page. And now we have to analyze this text. What we can do? We can do using natural language processing. First of all, we do pre-processing. Pre-processing is a step where it involves tokenization, stop words removal, normalization. Normalization consists of two things, stemma and lemmatization. And then using natural language processing, NLP, we will also get parts of speech taggings. And after that, we can see how advanced features work here in order to find the keywords for the web page. These features and keywords are not topic that is included in our course, but you can also still use them. So once we have a text, then next step is like a tokens. Tokens is a comma separated words or space separated words based if the words are separated by comma or if the words are separated by space. So in our case, our words are separated by space, so we use space separated words. So we can see tokens making a complete sentences into separate words or tokens. Why we do that? Because it would be easier to analyze tokens rather than a complete text. In order to understand the language structure of the page or text, we need to tokenize it. So tokenization is the process of making text comma separated words or space separated words. So we can see here BBC home, we have double space, even space is a word here, breakings, news, world. So all of those words available inside the text becomes tokens. Now it is easier to give input to the next steps. Now we can find the second step is stop words. Stop words are those words which are frequently used. Frequently used means that they helps to make sentences like making in grammatical way of making sentences. For example, is, am, are, was, I, can, we. These are the stop words, are the most frequent words in the text. So we can see from the text what stop words are available here. For example, we can see, for example, in is a stop word, and the next stop word here is again in. On is a stop word, and then we can see which is also a stop word. The is a stop word. Off is a stop word here, and we is also a stop word. So now we can find different stop words. Why we need to find stop words? Because these are not useful words. We have to remove from the text in order to find the main content or important words from the text. So we have to remove all of those words from the text. That's why we separate them as a stop words. So there are like programming libraries that helps to separate those words from the text. So you don't have to worry about the programming. Just you need to just utilize this tool in order to analyze the text. After that, we can do some normalization based on text. What normalization basically makes, normalization is making converting words into the base form. Base form, for example, if a word is in a used as a past tense, or in the third 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 as verb is a third form, second form, third form, it will automatically convert into the base form or first form. So for the stemma, you can see stemma requires a tokens as an input. So then it changes the words into the, for example, we have BBC Home Break, BBC Home Breaking. So breaking becomes break in our stemization. And then we have what others? Yeah, you can see bussy. We have a text business, it makes it bussy. That is a problem with, that is what I was showing in the stemma. Stemma is faster. It does, it basically it chops the word from the ending of the word. So it doesn't see the actual meaning or actual form of the word inside the dictionary, any data set or in a database that defines the word or logical way. That's why we use the lemmatization. Lemmatization work perfectly because it watches every word, it observes every word inside the base form of the dictionary that is defined by the natural language processing. While stemma does is like a faster, it chops every word from the end of the word. But the lemmatization doesn't. However, lemmatization is slower than the stemma. So we have to choose in between stemma and lemmatization. So here in lemmatization, we can see breakings become breaking is still the same, and business is the business. It was a bussy before there, and innovation was innov in the stemma. You can see innov, and now in lemmatization it is in the correct form. After that, we have the POS, parts of speech tagging. Like a parts of speech tagging is the nouns, adjectives, verb, grammatical parts in English language. So it changes the words from what they are. For example, if it is a noun, if it's an adjective, it is a verb. Because nouns, adjectives, verbs cannot become a keyword for the advanced analysis. Like we need the keywords for the web page, so verbs cannot become a keyword. For example, somehow one word can become a keyword from verb, or two words from adjectives become a keyword. The rest of the other keywords come from mostly 90% from the nouns. So we have to separate from that. Okay, if we want to choose keywords from the list of the words, it should be like a nouns. What is research says about that? After parts of speech tagging, so every different language, for example, Finnish language has their own grammar, and English has their own grammar. Based on the language, every single language has their own parts of speech tagging. So I don't know about the Finnish language. If you know more, you can utilize and you can apply more POS taggers using language oriented POS parts of speech taggings. But rest of the things, for example, tokenization, start words are the words given by the libraries in the any programming language. So you can search by using Finnish or any other languages. Same way, we can see last two advanced buttons are sections like a feature and keywords. Features, we have words or tokens. We can see how many times a single word appears. We can analyze how many times a go appear in the text. Go appears like a 68 times, and BBC appears like 27 times. And then we can see text, what HTML text a particular word appears. We choose limited tags as a feature because we don't want to see all of the tags, but there are like many tags, like more than 200 tags available on any web page based on HTML. So we just make sure that we select the top high ranked most important, like headings, title, and then URL of the web page. These are most important web page or places where the word gets more important are value. For example, we choose five different features like and what tags they appear. For example, from header 1 to header 6, then we choose anchor tag where, and then we just also choose title and URL h, URL header, and URL. We divide the URL into two parts. So these are the tags that, for example, BBC appears in the H2A, anchor and title and URL H part, header part. So after that, it gets a score for each individual word. For example, it gets a score for that go how many tags it appears, and it gets scoring on manually by choosing the importance and the tags. We use machine learning then to get a score for each word, and then we also use some other techniques like clustering in order to get rank the score based on different techniques. But in this analyzer, we choose like a manual scoring, like for if the word appears in the header two, it gets two score. Why we give them the score? In order to choose a limited number of words. We cannot choose all of those words, like there are like 1000, 2000 words tokens. So we cannot choose 2000 words token as a keyword for the web page. So that's why we just make them limited, like 5 words or top 10 words based on the score. After that, from these words, top ranked score, like these 10 words become the keywords. For example, you can see the keywords now: BBC, US, ago, news, everything is there. So you can also change the web page based on, for example, my university main web page. If we click on enter, and it changes the text here. Again, text of the web page has been changed. Now tokens, star words, schema, lemmatization, POS tags, and features and keywords. And same way, you can apply many things as you can. If I say tori.fi, it's a Finnish language, it works, but the POS tag doesn't work properly maybe. So this is like a text from Finnish language, and we will have a tokens, and then Star Wars. I don't know about this stuff Finnish Star Wars, but they are wrong. Like it doesn't work for the Finnish language here. And same way the lemma and stemma doesn't work here. POS doesn't work properly here. Feature works very well, and keywords are also working very well here. So lit part, Tori, move is like sale, Osta is buying, Netisa annate ilmoita. Ilmoita is announcement. Ilmoita, yes, announcement. Ilmai sexy free. Like, yeah. So you can test the tool, and then you can analyze what we can do with the text using data analysis or text mining, web content mining. Thank you very much for watching this video. Hope you enjoy the video.